Remember this? Well, I came out here. I have been out here, been a couple days since I've been out here. And I went to turn this on, and nothing. Nothing at all, no output voltage at all. And if you look closely, these are the caps I replaced. They're bulged on the top. I don't know if you can really see that or not. There's 161 volts on this. So this is working, but this is dead again. So I can feel a bulge on both of them here. So we're going to go back to the high voltage capacitors, the 35 volt ones, because obviously 16 volts, that's what there is, 100 microfarad, 1,000 microfarads each at 16 volts. It's not enough. So physically I can't get the 35 volt ones in here. So we're going to put them on the outside again. And of course I need this dehumidifier in the shop here. And I don't want to be running my bench power supply 24/7 for the dehumidifier. It shouldn't have to do that. It's the only 9 volt 3 amp power supply I have in the shop. What I think I'd like to do once I ever get my car back, still nothing. I stopped over there today. He says he hadn't had a chance to look at it Saturday. I talked to him last Friday. And there's no update. Somebody had said that the TCM computer, I got an email from one of my friends, that is not the case, because I talked to him over there. He says the transmission computer has nothing to do with it. I didn't even know there was a transmission computer. Now this is the main computer near the battery as you lift the hood up. Not the TCM, which is the transmission computer module. It has nothing to do with it. The problem we have is ignition. It's either the wiring or the computer. So he's going to try to get at it tomorrow, and maybe if he gets a chance today. So meanwhile, I'm still without the minivan, and it's getting miserably hot again, and there's no AC in the big van. It's not bad in the shop now. So we got absolutely no voltage coming out of this. Everything's ice cold. Now, when I put these caps in, this thing here was running super hot. This draws exactly 2 amps. This power supply is designed for 3 amps. I don't know what I did with the other half. Oh, it's right here. Upside down. Of course, of course, of course. Three amps. Okay. So obviously, the ones that came out of there was the same value, 105C, 1,000 microfarad, 16 volts. Well, 16 volts is not enough for the spikes that are in there for the, and it eats them up. So, they're bulged. You may not be able to see that on the camera, I don't know. But we need higher voltage. Now when I had 35 volts in here at 2200 microfarads each, They were running lukewarm even then. So you actually, in my book, you need a higher voltage. Even though they say that the ESR for, like the ESR would normally be higher on a higher voltage of the same value capacitor, you need that. Otherwise, you're going to be replacing these every month or two. Now, it wasn't that long ago that I replaced these. And they're pretty hard to see in there. So, what I think I am going to have to do in the future is make a good old-fashioned analog 9-volt power supply. I call them analog. You call them linear, I call them analog. In other words, none of this switching power supply crap. This way, it's not going to make all kinds of noises in my radios when I'm working on them. I don't have any problem because that's an analog power supply right there. That is not a switching. Everything else in this world is switching. Your camcorder power supplies and everything. So I'm going to look into making a 9-volt DC 3-amp power supply. Oh well, it did have a transformer in it. It did have a 5-volt regulator transistor, a TO, let's see, a 2N3055 style case, 5-volt. It had a transformer in it. But obviously, I stripped it out, so I took the transformer out of it. It's a capacitor meter. So, I wanted to build a linear 9-volt power supply. But I don't have a 9-volt regulator transistor, so what I'm going to probably do is if I can find a transformer to this, or a transformer, and see if I can throw together something, I don't know, maybe with bleeder resistors or something. This thing draws, as I said, this thing draws just a little under 2 amps, about 1.9 amps. So you figure 2 amps, so I'm going to need a power supply that puts out 3 amps. This thing here claims 3 amps, but it keeps blowing these capacitors, and if you look back on my other videos, you'll see the video I made about replacing them. So this is basically what's left of it, and I don't work with ICs. I used to experiment with them way back in the 70s, but this is probably a good project case to make a power supply in. But all I want to do is to just make a simple thing, nothing fancy, nothing pretty, just to run this. That's all. Just to run that. I don't need anything fancy. So let me go look around here and see if I can find something. I doubt it. What I'll probably end up doing is doing what I was going to do is take these caps out and not put them back in here, but run wires outside the case and mount them on the outside of the case. That way it'll be away from this heatsink in here. And they can be replaced easily. But what I'm going to do, I'm going to go back to the original idea. when I first did this. Put higher voltage, 1,000 microfarad or more capacitors. Now the question is, my eyesight's so bad that I don't know if these caps are in parallel or not. The only way I'm going to know maybe is with an ohm meter, if there isn't any low resistance circuits in there. Whether they're in parallel with each other or not, I don't know. But you can probably see that they're bulged up a little bit. Alright, I can't find the transformer that was in that capacitor meter thing there that is down here. But I found this UPS uninterruptible power supply transformer. We're feeding it with 118 volts. We're going to the dim bulb, which is up there, and we got it on the dim bulb because we want to make sure there's no shorts. Apparently the red is the center tap, and we are getting 8.1 volts AC from the center tap to the white, and the center tap to the black. Well, actually we're getting 10 volts now, and I was getting 8. See if my line voltage went up. Nope, that's still getting 8. Well, now it's 8. That's crazy. Wiggle that wire, I don't know. And we are getting from the red, which is the center tap apparently, kind of strange, but these UPS power supplies, wiring is not always what it should be, I guess, making common sense. But we're based this on this red being the center tap of the low voltage winding. And if we go from the white to the red, we're getting little over 8 volts. And to the black, which we had on, you notice I'm getting 8 volts there now. Why I was getting 10 before, I don't know. All right, now if we get our readings between the black and the white, we should have 16 volts, and we do. So, I want to make a 9-volt DC power supply. I do not have a 9-volt regulator. I thought I had a 5-volt regulator, but that's not going to do me any good anyways. I know this is going to handle a lot more, judging from the wire size on the secondary low voltage windings. It's going to handle a lot more than the 3 amps, and it only needs 2 for this. Now I've got some diodes, but they're not going to be heavy enough. I got some 3 amp 1000 PIV diodes. I may have some low voltage 20 amp or 30 amp diodes, but I want to make a bridge. But I don't have a voltage regulator, so I think in simplified type of linear power supply, I think we should make a basic, simple, full wave bridge into a large, maybe 2,200 to 3,500 microfarad, 25 volt rated at least, electrolytic, But we're not sure what the voltage is going to come out of that, because we're going to be using 16 volts AC going into the full wave bridge, into the capacitor, and whatever the capacitor will charge up unloaded, and probably a bleeder supply or something, and I can tap off of that for the 9 volts. Or I could put a series resistor to get it down to 9 volts, because when this is on, it's going to pull down whatever. If I put a resistor in series with this, I'm only thinking now, this is the thinking stages. If I put a resistor in series, well, let's say this is putting out, we don't know what it's putting out yet, because I don't, as far as the DC, because I don't have the capacitors and I don't have the diodes. I got to look for, see if I got any. I can't find nothing in this shop. I know I have a smaller transformer, but I think this would probably be good. There's no real way to mount it. It warns you that the transformer core is not grounded. It could be a shock hazard. But this don't have to even be in a case. It can be sitting on a bench somewhere with wires and taped up, electrolytic and the diodes, and that's it. So I think this would probably work good, and we know it's not going to run hot, and we're not going to blow out the electrolytics because we don't have the pulse rectifying the high frequency 100 kC or whatever it is. And then electrolytics are not made for that stuff. So a good old-fashioned linear power supply is what I want to try to make here. So let me go and look and see if I got the diodes. Well, I can't find my real high amperage diodes, which came out of junk power supplies, like battery chargers. But I have a 1N5408 3 amp 1000 PIV diode. I have a bunch of those. And we're not going to be drawing more than 2 amps off of this thing unless the output shorts. And if we're careful and we use the round connector, which is what I got on the back of this thing, and wire it carefully, it should be okay. So now what we're going to do is to make up a bridge rectifier and see if we can get that, see what the output's going to be. And what we're running here is 16 volts from here to here, 8 volts from here to here, or from here to here. So we can use a full wave bridge on that. Be right back. Okay, I threw together 1N5408, so it's a 3 amp 1000 PIV diode, so I made a bridge. And we're running on the center tap, and we're putting out 10 volts, a little over 10.5 volts, but that's without a filter cap. Because when we go to the full output here, which is 16 volts AC, we got too much and we need to go for 9 volts. So the next step is to add a filter cap here, and we'll do that and we'll come back. Okay, we've got 1,000 microfarads at 25 volts, just what I dug out of the box. And we've got 21 volts. But we're using the full 16 volt AC. So let's go to the 8-volt winding. There's 8 volts on each side of the center tap, and this is the center tap. We got to wait for that cap to discharge. So I'll be right back. We're going to discharge it, and then we'll be right back. Okay, I discharge it. Now we're getting 10 volts. We're not really getting any more than we were with with no cap. That's strange. And remember, there's no load on this. Well, I got to do a bunch of experimentation, because everything I do is experimentation, and I don't use math. So I experiment and try this and try that. I use very, very basic math. Can't do formulas, so I'll admit that. We're a little over 10 volts, and we need 9 to go here. And I know it's not going to run, so we may have to use the full winding on this of 16 volts, have 20, and then we'll have to drop it down with bleeder resistors at the output. But I'm not giving up on it. It's just in the planning stages now. I'm experimenting, actually. But I need this dehumidifier in here. Everything's going to get musty in here, everything. So I may be forced to temporarily hook this back up here, because once I'm not going to mess around with this thing. It's only going to blow caps again. These are basically throwaways. When the caps go, which is usually what it is on the outputs, throw them out. They're not going to last. They just run too damn hot. I'd rather have a good old linear power supply. So we're only getting about 10.3 volts. But you know what? I don't know. I'm going to try to, if I can find a plug to go in this, I want to see if this thing will run, see what the voltage drops down when I plug in my dehumidifier, which draws 2 amps. We got to experiment with that.